Okay, it started.
All right.
Yeah. Let's see.
Okay, so I've got 1 and 2. You do probably have to open up the applet too there.
So the total area under a normal distributive curve must equal, isn't it 1?
1. That's what I got.
Yeah.
I just barely read that one, so. Under certain circumstances, a normal distribution curve can drop below the x-axis.
That's false.
That's false.
Yeah.
It gets close, but it's never supposed to, I think, actually touch the line.
Mm-hmm.
And then a normal distribution curve is symmetric.
That's true, right?
And that is
I think, yeah, it should be, yeah.
okay. And then looking at question 6, which of the following elements of the figure represents the z-score? And that C is what I'm putting, right?
Yeah. Yeah.
Yeah. All right.
Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
Probably B.
That would be, yeah, B.
That's what I would say too. According to the 68, 95, 99.7 rule, what percentage of the data from a Bell distribution will be within 1 standard deviation of the mean? Isn't that the 68?
Yeah.
Because then it goes 68, then 2 standards is 95, and 3 is 99, right?
Mm-hmm.
Okay.
Yeah.
Is it 0.68? Let's see. Oh, okay, no, just the number. All right.
Yeah, you gotta
Now I'm a little
careful
paranoid.
about that one now.
Just plain old 68, right?
Yeah.
Okay, suppose the z-scores come from a standard normal distribution. Use the applet to answer this question. What proportion of the z-scores will be between -1 and 1?
So you're in a decimal.
This one, it tells you to use decimals, so that's nice.
Yeah.
Okay, hang on, between 1 and...
If you, hold on.
Is it 68? So it's 0.682. Oh no, 683, right?
That's what I got.
Did you please how to do it?
I'm not sure on this one how to do that.
Did you open up your the applet, the normal probability app?
Yeah.
Okay, so click, see the zeros in the middle, and you've got the 1 deviation on the right and the left.
Yeah.
So you shade the middle, and then it gives you the percentage at the top of the area.
Oh, only the middle part. Oh, that's easy.
Between the two, yeah.
Okay.
So 0.688, right? Is that, help me out here, don't let me go astray.
Yeah.
0.683.
and then
0.683.
Right.
Yeah, and then 10 I got 0.955.
0.683?
Mm-hmm.
Yeah.
Yeah, okay. Sorry, I looked at the wrong one. And then
2.
wait a second. I just changed one.
So that's 0.955.
Yeah.
point, okay, and that's
Putting it on the wrong.
955, right?
Yeah.
Okay.
Yeah.
Okay, and then
3. Wait. Oh, wait.
fills the whole thing.
But yeah, it does. 0.997.
Yeah.
0.997. Yeah.
So that follows the 6895997 rule.
Okay. Yeah, so the values match. That's the first one, right? Yeah, and 12.
Mm-hmm.
Okay, and
Okay.
I got 0.238, but I don't know if that's right.
What did you get? Sorry.
0.238.
Yeah, I think that's right.
Okay, so so you have to get the z-score first, Lisa. If you get that too. I worked through this last night, so otherwise there's no way I'd know it. So you take 0.60 that they give you for the
Yeah.
less than, you minus the mean, which is 0.65, divided by the standard deviation, which is 0.07, then you get a negative 0.714.
Uh-huh.
So if you put that into the applet down at the bottom of the z-score, then it gives you the,
Okay.
you have to, on those, you have to get the z-score first. It's kind of confusing. You do the same thing on the next one, and let's see. Oh no, that one's different.
So for the z-score, you would put in the negative 0.714?
Yeah, for the z-score, and then it'll give you the proportion at the top.
Okay.
0.2376, and then you just round it up to 3.
Got it.
Okay. The same thing, and this is, so this is more than, that one was less than, and this one is more than.
That's just the right side. Let's see.
I don't know that one. Did I do? Let's see. I did work through that one. Let's see.
The same as the previous one, but it's
Not
asking
negative.
instead of less than, it's more than. So wouldn't that just be the right side of the bell curve? Or no? Or
Let me put that in.
or the middle and the right side. Oh.
Which one are you guys stuck on?
13.
No, 14.
14, sorry.
Oh, okay. How do you do this one?
It's the same answer, isn't it?
It is, because
you get point.
Because they're both 0.05 away from the standard deviation. So
Yeah.
just for this circumstance, they're going to be the same.
Okay, that's what I got, but I thought it was wrong.
So it's 0.23.
It's the same, but
So
you're right.
it's more than or less than. Is that right?
For which one?
14. So it was more than. This is the same answer.
Yep.
0.762. I think it's 14 and 15.
Because in 14,
that's what I was thinking, because it's more than.
14, they're asking more than, and then 15, they're asking less than the higher part. So they're both using the same z-score.
Tricky.
14 is 0.762.
762, right? I got that one. And then 15 is back to 0.023.
No, 15 is 0.762 as well.
When you do the score for that, what did you guys get?
For which? For 15?
Yes.
0.762.
Okay, I got that wrong. I did the math wrong. But you did 0.70 minus 0.65 divided by 0.07. I just want to make sure I know how to do this.
Oh, yeah.
Okay, so for the point minus the z-score for the 0.60, I got a negative 0.714, and for the 0.770 for the 0.70, the 70, I got positive 0.714.
Yeah, same here.
So why wouldn't those two be the same, the 60 and the 70?
No idea.
They're the same.
60. Which is, when you put that z-score in the app, that's maybe I'm just reading the thing wrong too. That could be. The z-score for both of them is 714 because one's negative and one's positive.
Mm-hmm.
That, yeah.
7.5.
Does that just mean if the 0.7, if it's 0.714, then the other side is the negative 0.714, right? So
Right.
it's the same. So they're the same, essentially.
So that's less than 0.7.
Mm-hmm.
I'll shade this. I'll unshade that.
Yeah.
And that's more than 0.6.
So, all right, so 14 and 15 would be the same.
Yeah.
Okay. All right, I've got it. Okay.
Okay.
All right, and then 16, find the probability that a randomly selected person will have a protein requirement. Ooh, 0.607. Remember that to find the area between the two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. Make sure the answer is positive. This is a probability that a randomly selected observation will lie between the two values.
So it would just be 0.525.
I didn't get that. Let's see. So if you're shading,
Because you just shade the middle portion.
Oh, yeah.
shade to the left of the z-score and to the right.
Mm-hmm.
So isn't the shaded area gives me 0.4752? To the left and right of the z-score, not between them. Is it between them? Then yeah, it's 524.
In this case, you don't shade to
Is that what you're asking?
Okay. So you don't shade to the left and right
because the z-scores are the same.
because the z-scores are the same?
Mm-hmm.
Okay.
Okay, so it's the middle one, so 0.525. Okay.
Do you want to go
Did you
ahead?
get that one, please, too? Before I did, probably, huh? Okay. 17 took me a while last night. I was working on it.
9.6.
Percentile.
These are shaded less than, so both of these, they only overlap right here.
Yeah.
That's why I only highlighted them.
Okay.
Scores, you have to put in each z-score and then see where they overlap. Subtract the area.
So did you guys get number 16 then?
0.525.
Yeah.
Yeah.
Okay.
Yeah.
I'm not sure how to do 17.
Okay, it has the example. If you have your lesson 5, the big packet, the normal distribution,
Mm.
go to,
Do you have it open?
it's under 3.4, calculating percentiles using a normal distribution. You get to use algebra.
Oh, there it is.
Yeah, so what I did was I took the 0.60 plus a 385, which, let's see. Where did I get that?
Mm.
So,
Okay.
Okay, so you have to get the z-score for what 35% is first.
Mm-hmm.
So that's what I did. I went to the applet and put in 35% at the top.
Oh, you can do that?
Yeah, I put in 3.5, I thought.
Oh, yeah, sorry, 3 point.
Yeah,
It is.
0.35, sorry.
Yeah, I think I said 0.35, but I might have said 0.35. So
Okay. I see.
yeah,
So the z-scores.
0.358. It says to take it to 3, so I did 358. And okay, and then the formula that I used was, okay, they give you the mean of 60 and the standard deviation is still 0.7. So I put 0.60 Z formula. Z equals X minus mu over standard deviation.
Yeah.
Okay, so the formula ends up being 0.60 plus 385, and then in parentheses, 0.07 parentheses equals X minus 0.06. So you're doing algebra here. Wait, let me back up. Let me give you the first formula. Let's say
I see that formula actually here.
Z is 0.385. So that equals the X. So the value that they're giving you is 0.60. That's
mean is 6.5.
yeah.
Not 0.60.
Oh, okay, then that one's wrong.
It's okay. Happens to me all the time.
I don't. So it's the same formula though. So the value is X minus 0.65 over 0.07. And then with even algebra, you times the point, they cross each other out. You times 0.07 by each side. And that gives you 0.65 plus 385 times 0.07 equals X. And they need to solve that for, change it because I put 60 in there the first time. I got 27.6.
Got 6.623.
So you do the 65 plus 385 times 0.07.
It's negative 0.3.07 x minus 0.835 parentheses plus 0.65 equals x is what I have. Oh, 0.07 times negative 0.38.
Marie, what did you get?
0.623.
I did way wrong.
0.623.
What did you guys get?
I got 27.6, but I think I need to move. No, that's what I got, 0.6.
Yeah, that's what I thought I was off. I don't know. I got 27.54, but
See, I had 5.5 at first. That's because I used 60 instead of 65. But when I changed it, it went up just a little bit, 0.65. At 27.6. That's what I have.
But then you still have that negative 0.06 on the other side that you have to add to get x alone, right? Or is that the
negative? No, it should be point.
The formula is negative 0.385 equals x minus 0.657. So to get x alone, you multiply 0.07 by each side. 5 times 0.07, and that gives you like negative 0.02.
Where'd you get the negative 380?
And then that's your z-score.
Why is it negative?
35th percentile, so everything from the first line to the left. So when you go to the app, you click everything from the first line shaded left, and then you type in 0.35 at the top for negative 0.385. Does that make sense?
Okay. You may have lost me. Okay, so on the area, type 0.35, right, for 35%.
Mm-hmm. Yeah, so 35 percentile means that it's smaller data, right? It's not a big group of the data.
Right.
On the normal probability app, it'll adjust those bars based on your percentage. The top represents your percentage. And to the left of the first red bar, that z-score that you put in.
It's negative 0.35.
So if you shade only the left side of the first bar, want the 35th percentile, small group, and you put in 0.35 for the area. What did you do?
I don't know, it's done that to me so many times.
You put in 0.35 representing the percentage. It moves the z-score to negative 0.385.
Okay.
You see that? Does that make sense?
Yeah.
Yeah, it does.
So you got 35 times 0.07.
And then
X minus 0.65. Right. Then,
yeah, so x minus 0.65, because that's your mean. The standard deviation, which was 0.07 originally given. And then you just solve for it. You can kind of check your work is like if the number you get is like way far away from all the other data, like the other data they're giving like 0.65, 0.60. If your data is like way like 20 in the 20s or like a whole number, you know your data is probably wrong because it's not close to like the data we've been talking about. If that makes sense. That's how I always check it. Anyway.
Yeah, makes sense.
Yeah, it does.
It's kind of tough to pick up on, honestly. Especially using that like app. Frustrating sometimes.
okay, yeah, you got 0.623.
Yeah.
You still can't get that. What am I doing wrong?
Did you make sure you use the z-score on the left side of the equation so it's negative 0.385?
I did.
Okay, what did you get?
27 something. I just erased it. Sorry, I'm gonna just do it one more time here.
Okay, I'll do it with you. So negative 85 times 0.07.
And then I get 28.19, right?
Wait a minute. What did you get? Was it 0.623?
Yeah.
Mm-hmm.
Yeah.
Job. Yes.
Okay, so if I take the negative 0.385 times 0.07, I get 28.19.
No, you should get negative 0.02695.
I just put it all in my calculator.
Point is thing.
Okay. Alrighty.
Did you get it?
You have to get them all in the right order. So, woohoo. Math is not my friend. That was 13, right? No, 17, sorry.
17.
I went back up there.
So 80th, we just do the same thing. Right. Okay.
Basically. Except this time, do you know what you're shading on the probability app?
Other side.
I don't know. How do we know from that?
Yeah, that's a good question.
This, so if you look at this from left to right, if you look at the graph from left to right, it basically represents 100% of people. So the bars represent, so.
Yeah, the upper 80% would be the right quartile there, right?
What's that?
So the right would represent the more than 80%. Shade the right.
Yeah.
Shade the middle and the left. So I look at it as like you're filling up your container from left to right. You have 35% to the first line, and then you get percent. So it's everything from the second line down. You can only fit 20% more in there. Does that make sense?
So you shade the two.
I know, it's kind of hard to pick up on.
0.649. Is that?
What's that?
Right. 0.649. You're shading the two to the left. That gives you the area.
That's what it gives you with the z-score you have right now. But you shade those and then you put in the 0.8 to make it adjust so you have whatever is at the top is the percentile. So if they're giving you the percentile they want, you know you're going to have to put that in the top.
Oh, so then I need to put in
even if you
0.
Even if you only shade in the bottom one and you don't do the middle, 0.8, it'll correct it and shade both of them for you. What you're looking for.
Oh, okay, I got it. So,
makes sense?
0.842. Is that what you got?
Are you going to use the positive or negative z-score?
So,
that's a good question.
I really did.
Shaded both, so you're going to build up to the second line now.
So it should be positive because it's past 0, right?
Does that make sense?
So if it's past 0, it's positive? So, because it's on the right side, right?
Zero and the 1 represents standard deviation, like what we're looking at. Does that make sense? So that might be confusing. The bottom numbers, they don't represent your data. Like it just represents -1 to 1. That's 1 standard deviation from the mean.
Right.
To 2, that's deviation away. When you're looking at percentiles, you're not looking at standard deviation.
Okay.
So don't let them confuse you.
Yeah, that is a little confusing.
It is. So the shading and like it goes up because the mean is the peak there. So that's just on a test or whatever the data is giving you. And if you want to know what 80% of the people scored, then you want to look at that second line. 80% of the people did this or less than. Makes sense?
Okay.
Confusing. I don't know. Might not be helping.
So the question is the 80th percentile for the protein requirement for adults. So if it's a requirement, it couldn't be a negative, so it has to be a positive number. It couldn't be a negative requirement, could it? So I've got
No,
point.
you're right. It's the positive number.
Oh, okay. Well,
If they were asking for a smaller percentile, it could be a negative number because of.
right, if it was smaller down, yeah.
Yeah.
Okay.
So basically, if it's less than 50%, you're going to use the bottom, the negative number. If it's more than 50% of the data, the positive number.
So with the 17 a negative one, I just put that positive.
No, your answer for 17 was a positive, but I'm talking about which z-score to use.
Oh, okay. Okay, gotcha.
Yeah.
Okay. Oh, wow. Well, that is it, right, guys?
Mm-hmm.
Here comes 100%.
Wait, so what did 18, what answer did you get then?
0.842.
Oh, it's just asking for that.
0.709.
What is that? That's not that number?
We don't have to use the same
No.
formula as we did on 17?
You do use the same formula.
Oh, okay.
So, but you're not using the same z-score.
Okay.
0.842. 7 plus 0.65. Does that make sense?
Yeah.
Yep. Oh, I did that.
With all these decimals, it's easy to make a little calculator error too, so you gotta be careful.
It's 0.709?
That's what I got. 70894. Yay.
Okay.
That's the one.
Thank you for helping us.
Yeah.
No problem.
You know, I don't know what I would do if he wasn't taking this class too.
I'm actually retaking it, so I'm not that smart.
He got a B last time.
I guess
Oh, really?
it was close to a B, but I don't remember.
Yeah.
Wasn't good enough, huh, for you?
1 and A.
Good med school.
I don't blame you. Okay, are you
Yay,
guys
100%.
Yeah.
Cool.
I could not get 100% without help.
All right, nice job, guys.
Yay, thank you. All right.
Thank you, thank you. I hope you get feeling better.
Thank you.
Bye.
You guys have a good day. I'll see you Tuesday.
All right.
All right. Yeah.